In this video, we're going to do some guided exam question practice, and we're taking a look at the 2019 science paper, and we're looking at question 10. It was on this topic of Earth and space, and it was specifically about eclipses. Now, again, as usual, the early parts of this question are very, very, very easy, and later parts, a little bit more difficult, but nothing you guys can't handle. All right, so again, quick notice that this was a 15-mark question, which means we have approximately about 5 minutes to complete it. Okay, so about 5 minutes. So set your timer now for 5 minutes and we'll get cracking and read it. Okay, it says answer questions A and B. So these two questions are both answered in the same way by placing a tick in the correct box. Now, it's really important that if it asks for a tick, that you do put a tick and you don't put an X, so you don't shade it in or anything like that. You actually do what it says to do. So it says to put a tick, so that's what you should do. Okay, so the next, let's have a look at what it says here. It says a star and all of the objects that orbit it is called what? So you have three options, A, B, and C. Again, this is the most basic of all real Earth and space science. You just have to pick. It's checking, do you know your definition, guys, of what a star is? A star and all the objects that orbit it. So I don't think there's much explaining needed here. You have to go ahead and choose one of them. So either tick it on your exam papers, or if you don't have exam papers, just write question 10A and write down which one it is. Do that now, pause the video. Okay, so hopefully you made your mind up. A star and all the things that orbit it, that will be called, well, it can't be a moon because a moon and a star are not the same thing. And it can't be a galaxy because hopefully you know what a galaxy is. A galaxy is a collection of stars, and therefore it can't be this. A star and all the objects around it is a solar system. Okay, so you should have taken solar system. The next one, a system of billions of stars is called, so which of them is this? Pause the video and tick the right box. Well, we definitely know it's not a moon. I hope you know it's not a moon. We've ruled out solar system, so the one that's left is galaxy. So again, you could have known either of these answers here, really, what a galaxy is or what a solar system is. And if not, you could have read the question really, really carefully and figured it out. So a star and all of the objects that orbit it. So something like our solar system with our sun, all the planets, all the asteroids, all the comets that orbit around our sun, we call that our solar system. Okay, whereas a system or a collection that has billions of stars in it, that's not a solar system, that's a galaxy. So again, hopefully for most of us, I think for 99% of students, that's going to be a 30-second job, but you just have to be really, really careful that you do take time to read the question. The next bit is a little bit trickier. I'm going to explain, read and explain the diagram. It says the image below shows, okay, so it's showing us something, so there might be some important information here. Shows a planet passing in front of a star. This partial eclipse is called a transit. So this is a star, this is a planet going across in front of a star, basically. The brightness of light detected from the star decreases, so the light goes down, in other words, as the planet transits the star and blocks its light. Okay, so in other words, as something gets in the way of a light, you see less light. Okay, so it's like if you're looking at a window and someone walks in front of your view, you're not going to see the light coming in the window for a second while they go across. Similar kind of idea here. Let's look at the graph. What does it show? So here's the picture of basically we've got an X and Y axis. And on our x-axis, on our y-axis, we've got brightness. Okay, so here we've got brightness. And really importantly, the x-axis shows us the time. So as time goes by, then this white line here shows us the actual, how bright it is, okay, as time goes on. So here you can see, here, if we call this point A, as the planet goes across, the light is at this level, okay? If we call this point B, as the light begins to go across the star, what do we see? We see the level of light decreasing. So it goes down by a little bit. It's a little bit less bright. Here at point C here, the star is, or the planet is fully in front of the star. Now it doesn't block out the whole star, so the light doesn't go down to zero. Okay, if the planet was bigger than the star and it blocked the whole thing out, then the light would go down to zero. But it's not bigger than the whole star, it's smaller, so it only blocks a little bit of the light. So that's why at this point the light intensity is lower, the brightness is lower than it was when the planet is not in front of it. And then at point D, now the planet has fully transited and the light level is back up to its original level. So that's what we're seeing. One thing I wanted to point out is here to here is the amount of time that it took for the star to go across. We know this because that's where the light changed. So where the light begins to change here, this is kind of like B here, where the planet first starts to get in the way of the sun, that's when the light goes down. When the planet gets out of the way of the sun, that's when it goes back up. Okay, so that's really as simple as, that's as complicated as it gets there. Okay, so we've got a couple of questions. Here it says, the graphs below show how the brightness of a star changed over time. Okay, so how the brightness, so very similar to this up here, changed over time for two planets. So we've got A and planet B. Okay, so here's planet A and here's planet B. So we've got a similar kind of idea, guys, but obviously they're, you know, the graphs are slightly different because it was obviously two different planets, so they have a different effect, but it's still the same thing. Brightness is here and time is here. Okay. All right, so interpreting these graphs then, it says which planet, A or B, took the shortest time to transit the star. So pause the video, take a good look and see which one took less time. Write down the answer. Pause the video, do that now. Okay, so hopefully you saw, okay, so I'm playing the video if you've written down A or B here. Hopefully you saw, well, the time it took A was from here to here. It was this amount of time. So the question is planet B more or less than this? Well, here is where it started to go across, and here is where it finished going across. This here is definitely a bigger amount of time than it was for A. So my answer here, which one took the shortest time? Well, that would be A. A took less time. Okay, so hopefully you wrote down A. All right, I'm going to rub that out now because I've made a mess up here and I want you to be able to see the graph. Okay, what does it say now? It says which planet, A or B, again, is the largest, and give a reason for your answer. So this time you can't just write A or B. You have to give a reason for your answer. So pause the video, write down A or B first. Do that now. Pause the video, write down A or B. Okay, so hopefully you've written down your answer. In my opinion, the answer here is B. So hopefully you wrote down B. If you didn't write down B, that's okay. Write it down now. And now I want you to try and explain, why is B bigger than A? How do you know? Use your evidence from the graph to explain why B, how you know B is a bigger planet than A. Do that now. Okay, so it's hopefully you should only be listening now again if you've tried to answer this. Well, I suppose we know which planet is bigger by seeing how much light do they block out. Remember what I said earlier, that if this planet here, instead of being, okay, I'm going to rub this out. If this planet here, instead of being that red dot, was this red dot, it was that size instead of the original size, well then this line here would be, I think, would be quite different. If the planet was bigger, then the amount of light would be way lower because it would be blocking out nearly all of the light. So it's got to do with how much of the brightness disappears when the planet moves across it. Okay, so if you didn't write down a reason already, pause the video, do it now. Okay, so hopefully you said something like this. Give a reason for your answer. B is the largest because, oh, it's B because planet B reduces the brightness more than A. Now, there's a couple of different ways you can write that. You might have worded it slightly different. You might have said planet B because B is less bright than A. You might have said planet B because A is brighter than B. Like I said, there's a couple of ways you could word it, but it should mean the same thing. So examine your answer, see have what you have written, does it mean the same thing? So are you talking about how this brightness here reduces, it goes down lower brightness than for A? Look, A only reduces by this little bit. Okay, so B, it reduces less. You might have talked about that. You might have said planet B reduces the brightness more than A. Yeah, that's what I said. Sorry. Yeah, I'm not just repeating myself. So hopefully you guys get what I'm saying and that you've written a sentence that means something like that. Okay, so pause your timer now at this stage. We're only really going over the answers. We're going to pull over the marking scheme here just so you can compare. I think the first two are pretty obvious, solar system and galaxy. And then let's check in our answers here. We have A is correct here and B is correct here. And the reasons given are what we said. There's a greater decrease in brightness, which is exactly what I said here. Reduces or decreases the brightness more than A. That's exactly what I said. And another way they have given for anyone to approach it is this: it blocks more light. B blocks more light. You could have said that. So instead of talking about the brightness, you could talk about B blocking more light or A blocking less light, something like that. All right, guys, so that's that question. Again, pretty straightforward. We've been through all the short questions now, the first 150 marks of the paper. And I know I'm talking about my third year classes anyway. I know that you're capable of getting 100% on that section of the exam. We, very confident that we're going to get really, really, really high scores on them first 10 questions. All right, guys, that's it. We'll see you in the next one. We'll be ramping it up to slightly harder questions after this.